So we are discussing kinematics, and we done it about the graph, also the definitions, also the formulas. Today you want to discuss, I hope you want to discuss the mass, weight, and density or Hooke principle. You share with
Um, no, I already know mass density, volume. They're very basic. Can we learn Hooke's law?
Okay, come to the deformation.
Okay,
Okay,
but
today our
yeah,
topic is elastic deformation. First of all, can you have any idea about that? What is the meaning of deformation?
no, no.
Deform mean again create, again gain the original position. Deform mean d mean again, formed mean creation or regaining. Then if a body change its length or a shape, when we apply a force on the body and it's change its length or shape, and when we remove the force on that body and it's regain the original length or original shape, that type, that phenomena is called deformation. Today our topic is elastic deformation. Okay, in elastic deformation, first of all, we have two type of bodies, we have two type of material. Number one, plastic material or elastic material. Plastic material mean that material by which we apply the force and it's change its length or shape, and when we remove the force it doesn't gain the original position or original length. That material is called plastic material. And the material which regain the original position and original length after removing the deforming force, that material is called elastic material. Elastic material have a property elasticity. Elastic material have a property elasticity. Elasticity is a property of the elastic material in which by which they gain the original shape. For example, material bodies which get stretched on the application of a force and regain its original length and shape on the removal of the deforming force. What is deforming force? Have any idea about the deforming force?
Uh, n- Not forming.
Deforming force means that force which applied for change in length or change in size. For example, I have a spring here like that. Okay, and after that I apply a force on this spring and it's become like that. The force which applied on this spring by which it's changed the length, this force is
Yeah,
deforming force. This force is called deforming force. Deforming force mean that force which is applied on elastic object to change the length or the shape of the object. Mean the force which is applied to stretch the object. That force is called deforming force.
okay.
So when the removing of the deforming force are called elastic bodies, the property of the material of the bodies is known as elasticity. The property by which the material gain the original position, that property is called elasticity.
Okay.
Length of the object before applying the stretching force is called unstretched length. For example, I have a spring and before the applying force, the length of the spring is x. This x is called unstretched force. But if I apply a force on this spring and it's increased the length and it's become like this, then this length is called stretch length. Got it?
Got it.
In before the applying of deforming force, the original length of a material is called unstretched length. When we apply the force on that object and the length will be increased or decreased, it's called stretch length. And the second thing is extension. But before the extension, I want to write here something else. The stretch length, the length of the body after applying the stretching force, it's called stretch length, like this.
Okay.
Got the concept of stretch or unstretched length?
Can you repeat stretch length?
Stretch length mean when we before applying of stretching force on an object. For example, this spring have the length of 50 millimeter. Length is 50 millimeter
50 minutes.
without applying any force. Without applying any force, then that length is called unstretched length. But if I apply 2 Newton force here and it's increase the length towards 60, then this 50 minus 60 will be 10. Then this 10 length or this total length 60 millimeter is called stretch length. Stretch length mean that length which length are applying after the stretching force. The length after the stretching force, that length is called stretch length. And before the stretching force, the length is called unstretched length.
Okay.
Okay, now, अब हमारे पास आता है extension. What is extension? Extension mean the change. Simply, extension mean the change. Difference between the stretch length and unstretched length, it's called extension. Mean when we apply the force on a body, it's produce extension. Statement ये है कि when we apply a force on a body, a elastic object, then it's produce extension. And that extension is that extension is equals to stretch length and difference between the stretch length and unstretched length. Unstretched length कौन सी होती है? Before the applying force. For example, before the applying force, the spring have 10 millimeter length. But after the applying force, the spring will be, for example, it's have 15 millimeter. So the extension will be 15 minus 10 is equals to 5.
5 millimeters.
Then is an extension. Extension basically. Extension depend on the stretching force. Extension is directly proportional to that stretching force. If we increase the stretching force, the extension will increase. If we decrease the stretching force, the extension will decreased. अच्छा बेटा, ये जो extension होती है ना बेटा, it's two type of extension. One is positive and one is negative, but it is a part of A level, so हम उसको यहाँ study नहीं कर रहे. क्योंकि उसमें हम एक compress करते हैं. When we compress a spring, so that time also the extension will produced, but it is the compression form of extension. And when we stretch it, तो stretch में भी वो extension produce करता है, तो that time that extension is called the extension form. So there are two type of extension, but on O level हम सिर्फ extension की बात करेंगे, compression और rarefactions की बात नहीं करेंगे.
Okay.
Okay, now the extension is equals to the difference between stretch length or unstretched length. For example, this is a stretch length and this is a stretch length, unstretched length, and this is a stretch length. Then the extension will be, we have a formula here, 60 minus 40 is equals to 20 millimeter. In this, 50 minus 40 is 10 millimeter. Okay, now come to the hook. Because extension first time described by the hooks, and hooks create a principle here. Hook says that a material obey the Hooke's law if extension is directly proportional to the stretching force within the limit of proportionality. ये जो word है ना, limit of proportionality, it is very important for you. limit of proportionality. For example, I apply a stretching force on an object. मैं उसको स्ट्रेच कर रहा हूं तो वो अप्लाई करूंगा फोर्स तो वो स्ट्रेच होगा.
Yeah.
After applying a greater force, it will be more stretched.
Yeah.
But एक time ऐसे आएगा कि when I apply the force, for example, I have a rubber band. Rubber band पे I apply the stretching force. For some time, when I apply the force, so it will be extend. But after some time, when I apply the force, then it will be break.
So that means limit of proportionality is the time that is um, um, I don't know how to explain this, but that's the only point I can stretch. Other than that, it will break after that.
No, no. Limit of proportionality mean that point till where the force is directly proportional to the extension. After that point, it's also extended, but proportionality will be damaged. Only the proportionality damaged. When it's permanent,
Okay.
when it's breakdown, it's called limit, elastic limit. After the elastic limit, an object is break it. यानी जो आफ्टर द इलास्टिक लिमिट होता है ना, वो जो आपका ऑब्जेक्ट है वो ब्रेक डाउन हो जाता है, इट्स परमानेंटली चेंज हो जाता है. Before that, we have a limit which called a limit of proportionality, and limit of proportionality means that point till where the force and extension are directly proportional to each other. For example, I draw a spring, a graph here. Let's suppose, for example, I draw a graph here. Okay, wait a while. From the graph, I want to clear it. This is a extension load graph. Okay. In this graph, I mention here, in this graph from point O till X, it's a straight line. The gradient straight, it's mean it's directly proportional. It's directly proportional. Extension and load. Load mean force. Load mean force. Then force is directly proportional to the extension till X. This X is called limit of proportionality. This X is called limit of proportionality. After the X, when I increase the load or the force, it is extended. But वो जो extension होगी, it's break the proportionality. For example, here by 1 Newton force, it extend 10 millimeter. At 2 Newton, it's 20 millimeter. Mean the proportionality is by 1 Newton, it's increase 10 millimeter. But after the limit of proportionality, can you see here? I increase the limit of, I increase the force here, but exact at that force at 1 Newton, it's increasing till 15 millimeter. From 40 till 55.
Okay.
It's mean after the extension, after the limit of proportionality, if I apply the force, तो वो extend तो होगा, but the limit of proportion, after the limit of proportionality, the proportionality will be damaged between the elastic limit and between the extension and the force.
Okay.
Got it?
Yeah.
अब अगर ग्राफ पे आ जाओ ना, तो ग्राफ पे बेटा दो पॉइंट्स हैं, one is X and one is E. This E is called elastic limit. After the elastic limit, if I apply the force after the elastic limit, till the elastic limit ये होता है कि object came back to the original position. For example, a spring. Then if I apply the force till the elastic limit, it will be bounced back or regain the original position. But after the elastic limit, it's permanently changed. मीन वो परमानेंट चेंज हो जाएगा, उसके बाद वो वापस अपनी पोजीशन पे नहीं आएगा, अपनी लेंथ को गेन नहीं करेगा, बल्कि जैसे है वैसे ही रह जाएगा. मीन या तो अगर रबर बैंड है तो टूट जाएगा, अगर स्प्रिंग है तो एक्सटेंडेड फॉर्म में ही बच जाएगा।
गिर जाएगा नीचे।
गॉट इट?
Yeah, got it.
Okay. And the x mean the limit of proportionality. X mean the limit of proportionality. Till the limit of proportionality, F is directly proportional to the extension. Mean load is directly proportional to the extension. But after the x, if I apply the force, तो क्या होगा? एक्सटेंशन तो होगी लेकिन वो प्रोपोर्शनैलिटी डैमेज हो जाएगी. Till the E mean elastic limit. Till the elastic limit, when I apply the force, then till the elastic limit, object regain. When I remove the force, then object regain the original position, the original length or original shape. But after if I apply the force and I cross the elastic limit, so from that point, if I cross the elastic limit, तो ऑब्जेक्ट जो होगा वो रीगेन बिल्कुल भी नहीं करेगा अपनी ओरिजिनल पोजीशन और ओरिजिनल लेंथ को.
How is that possible?
For example, I have a rubber band. Okay, I have a rubber band. I apply the force. It's extend.
Yeah,
If I apply more force, it's more extend. If I apply more
yeah.
force, extend. But at a point, when I apply the force, then that time it's braked. But can you feel like that कि जब आप अप्लाई कर रहे हो तो जब आपने थोड़ा सा फोर्स अप्लाई किया थोड़ा सा एक्सटेंड हुआ इन द इनिशियली when I apply the force then it very easily applying the force and it will be extended very easily. But at a point ऐसा आएगा जब आपको फोर्स हार्डली अप्लाई करनी पड़ेगी उसको एक्सटेंड करने के लिए. तो वो जो हार्डली अप्लाई हो रही है ना बेटा, दैट इज द लिमिट ऑफ प्रोपोर्शनलिटी, दैट क्रॉस द लिमिट ऑफ प्रोपोर्शनलिटी. After the limit of proportionality, we apply the better force, but extension will be less. Sometime the extension are more and force are very less applied. तो वो डिपेंड करता है आपके ऑब्जेक्ट के ऊपर. ऑब्जेक्ट जैसा होगा वैसे. बट एट अ पॉइंट आफ्टर द इलास्टिक लिमिट जो होगा इट्स ब्रेक. मीन इलास्टिसिटी उसकी ब्रेकअप हो जाएगी. या तो वो ऑब्जेक्ट जो होगा अगर स्प्रिंग है तो एक्सटेंडेड ही रह जाएगा, वापस नहीं आएगा, और अगर रबर बैंड है तो टूट जाएगा.
Okay, so X is the point of limit proportionality.
Proportion.
Okay, and E is the point of
Elastic limit.
elastic limit.
At E, the object is permanently changed. At X, till X, the F is directly proportional to extension.
Okay.
Okay, come back to the point, the Hooke's principle again. Hooke says that the elastic when we apply a force on the elastic object, that time it's produce extension, and that extension is directly proportional to the force which applied. Directly proportional to the force which applied. Extension is directly proportional to the force. So we have a formula, F is directly proportional to the extension. Then remove the proportionality, that time F is equals to Kx. Then K is constant, which called spring constant or Hooke constant. ठीक है? या तो हम
Okay.
कहते हैं या आप उसको जो है वो आपका हुक कांस्टेंट कहते हैं, दोनों नाम है उसके. अच्छा, सम टाइम ये होता है आपसे कहते हैं ड्रॉ द ग्राफ ऑफ द लोड एक्सटेंशन ग्राफ, या ग्राफ दिया होता है, ग्राफ में से आपको कुछ वैल्यूज निकालनी होती है. या सम टाइम क्या करते हैं, सम टाइम दे प्रोवाइड अ टेबल लाइक दिस. दे प्रोवाइड अ टेबल लाइक दिस कि ये टेबल आपके पास आ गया एंड अकॉर्डिंग टू दिस टेबल आपसे कहा जाता है ड्रॉ द ग्राफ. तो अगर आप ग्राफ ड्रॉ करते हो अकॉर्डिंग टू दिस टेबल देन इट्स आल्सो करेक्ट. बट देयर इज अनदर क्वेश्चन दे आर आस्किंग इन दिस टाइप ऑफ क्वेश्चन कि वेयर इज द लिमिट ऑफ प्रोपोर्शनैलिटी, वेयर इज द लिमिट ऑफ प्रोपोर्शनैलिटी रीच्ड. तो
Okay.
लेना पड़ता है कि वेयर इज द लिमिट ऑफ प्रोपोर्शनैलिटी. देन आई कैलकुलेट द रेशियोज. फॉर एग्जांपल, this is 1 2 3 4 5. mean after the experiment, the 1 Newton weight is increasing. 1 Newton weight is increasing.
Increasing.
Calculate the ratio. From here to here, it's 10. Okay. To here, it's 10. Okay.
Then
Here, it's 10. Okay. From here to here, it's 10. Okay. But after this, from 40 till 58, it's
it's
18.
18.
The ratio will be break from 4 till 5. Then the limit of proportionality is between 4 and 5 Newton.
So what do I mark?
Only mark between 4 and 5. They says that in the question, they are asking in the question, where is limit of proportionality? Then your answer will be between 4 and 5 Newton.
Okay.
Got it?
Yeah.
After that if they want to know about make the graph, तो फिर हम जब ग्राफ बनाते हैं तो ग्राफ इज लाइक दैट कि आपके ग्राफ प्लॉटिंग करते हो, देन फ्रॉम ऑन द सॉरी on 1 we have 10, on 2 we have 20, on 3 we have 30, on 4 we have 40, on 5 we have
50.
8 na
No, 8. 60.
8. In the previous graph we have on 558.
Oh, 58. Okay.
Now till where we have a constant ratio, then we draw a straight line from 0 till that point. So from here, from a from 0 till x, we draw a straight line here. Then it's called
I can't hear you. Hello?
hello.
Yeah, I can hear you now. I can hear.
अच्छा, from 0 till x जो होगी वो straight line बनेगी, because it's a straight line. Then from 0 till x, it's obey the Hooke principle, because the extension is directly proportional to the force. But after the x, we have a curve, draw a curve here. Why? Because the proportionality will be break up. If the proportionality will break, then we draw a curve from x till ending point. Ending point is 58. Ending point is 58. So we draw a curve here. Got it?
Got it. Yeah.
Okay. If you write after the 4 Newton force, the limit of proportionality reach, it's also correct. Between the 4 and 5, the limit of proportionality reach, it's also correct.
But for example, if we need to like not answer but mark in the graph
Yeah.
to represent the answer. So how will we mark?
Then after the straight line, where the straight line is ended, that point is called the limit of proportionality, like this x. Like this x is the limit of proportionality. If we have a graph or they want to know about the where is the limit of proportionality now, if they want to know about the limit of proportionality in a graph, then we draw a point where from where the curve is started, or from where the straight line is ended. Till the straight line, we have the limit of proportionality. End of the straight line, the limit of proportionality is ended.
So it's
What?
between 4 to 5, we write.
No, limit of proportionality on the graph is 4. On the graph is 4. But if we don't have the graph and we have only the table here like this, so that time if they want to know where they reach the limit of proportionality, then we are saying that between the 4 and 5, it's reached the limit of proportionality.
Okay.
But if we have a graph, then on the graph, end of the straight line is the limit of proportionality.
Okay.
Done?
Yes, done. Limit of proportionality is where the force is directly proportional to extension, yeah?
Till where the force is directly proportional to the extension.
Okay,
Limit
till where? Okay.
the point till where force is directly proportional to the extension. After the limit of proportionality, the extension, the relationship between the force and extension is not directly proportional.
Okay.
ठीक हो गया?
Yeah.
Okay. Now come to the next. In this, we have a different type of questions on the situations when we have. These are the definitions. OX mean till the X point is the region where Hooke's law is obeyed. That is extension is directly proportional to the stretching force. X is the point of limit of proportionality, the point behind which the extension of an object is no longer proportional. The load bounce producing it is called limit of proportionality. If you want to define the limit of proportionality, then this is the definition of the limit of proportionality. The point behind which the extension of an object is not longer proportional, the load producing it is called the limit of proportionality. Now, E is the elastic limit. We already described it. E is its elastic limit up to E. The spring will behave elastically and return to its original position. Or return to its original position, original length, or original shape. Then return to its original length when the load is removed. Behind E, the spring will not return its original length when the stretching force is removed. The spring is left permanently stretched, hence the load is removed. Then it's mean it's called elastic limit. It's mean elastic limit is a point till where an object after the E, it's not regain the original position, it's permanently changed.
So elastic limit is the limit where the
object is changed at a point behind that E, behind the elastic limit, object is permanently changed. But before the elastic limit reached, object regained the original position when removing the force.
okay.
Now, spring constant. Calculating the formula, we have a formula here. We already described F is equals to E mean spring constant multiplied by extension. F is equals to KE. Spring constant of this spring is K is equals to F upon E. So 2 is a force, 2 Newton is a force, and the extension will be 20 in the previous graph. Then 2 upon 20 is equals to 0.1 Newton per millimeter is the spring constant in this example, which we describing here.
Okay.
Now, there's an example. A spring of original length 3.0 centimeter is extended to a total length of 5 centimeter by a force of 8 Newton. They're saying that a spring have a original length 3 centimeter. 3 centimeter is extended to a total length. यानी total length में वो 3 centimeter extend हो रहा है by 5 centimeter on a force of 8 Newton. When we apply the 8 Newton force, then वो क्या हो रहा है 3 centimeter extend हो रहा है of a total length of 5 centimeter. Calculate the spring constant. Calculate the spring constant. Then extension is
4.
5 minus 3. Original is 3. Then when we apply the total 8 Newton force, then it will be 5 centimeter. It's mean the stretch 5 centimeter, unstretched length is 3 centimeter. Then 5 minus 3 will be 2. Then extension will be 2. Then F is equals to KE. F is equals to KE.
KE.
A is equals to F upon E. So F is 8, E is 2. Then 8 upon 2 is 4 Newton per centimeter.
Okay.
Done it?
Yeah.
Okay, now come to the next. And other example. Sorry. In another example, they are saying that the same question is repeated only. Repetition, not repeating question, but they also says that assume the limit of proportionality of the spring has not been reached. If the limit of proportionality is not reached, it's mean the extension is directly proportional to the force. Extension is directly proportional to the force. Now, if the elastic limit of proportionality is not reached, so it means the extension is directly proportional to the force of the
Yeah.
has not been reached. Calculate the force needed extended if the total length of 6 centimeter. If the total length is 6 centimeter, we already know that the original length is 3 centimeter. Then till the 6 centimeter, the extension will be 3. Then 6 minus 3 is equals to 3. 3 is the extension. Then F is equals to KE. K, we already calculated in part A, the force Newton per centimeter. And the extension in this question, we have 3. Because 6 is total length, means stretch length, and 3 is the unstretched length. Then stretch length minus unstretched length will be 3. So 3 is the extension. So F is equals to KE equals to 4 multiplied by 3 is equals to 12 Newton. It's been multiply the 12 Newton force. That time the spring is extended till 6 centimeter.
Will the spring force always be the same?
Sorry?
Will the spring force always be the same? Like same value
Mm,
in one graph?
in one spring. In one spring. For
One
example,
spring.
change the spring, that time the force and the extension both are changing, because some springs are very easily stretched, no? But some springs
Hmm.
are very hardly stretched. Then if they need more force, then the extension will be changed. But if they are easily stretched, then the force is amount of
Okay.
got it. Okay, this
Yeah, got it.
formation is over now. In deformation, there is nothing to do anything else in the elastic deformation. This is whole chapter, elastic deformation. Till this point, the elastic deformation is over. Any question in elastic deformation?
Um, how many Hooke's law are there? Like here, I think he has like 3-4 points about the
About what?
law,
No.
about like related to elasticity.
Listen to me, listen to me. They are saying like that, na, कि वो parts में देख के कर रहे हैं. I want to explain the Hooke's law again. Hooke says that when we apply any stretching force on an elastic object, that time it's produce extension, and that extension is directly proportional to the stretching force. Clear ho gayi baat?
Hmm.
I repeating the same definitions. Hooke says when we apply a stretching force on an elastic body, it produces extension, and that extension is directly proportional to the force within the limit of proportionality.
Okay.
That's called Hooke's law. But if you directly mention here na Hooke's law, इस तरह भी आप कर सकते हो. Produce extension is directly proportional to the extension stretching force within the limit of proportionality. That's also called the Hooke's law.
Okay.
If they want to make the graph, तो आप ग्राफ भी उस डेटा जो मेंशन होगा x और y कंपोनेंट से उससे बनाओगे. लोड जो होगा हमेशा के लिए जरूरी नहीं है कि लोड विल बी एट द एक्स एक्सिस, आप उसको वाई एक्सिस पे भी रख सकते हो, फिर उस टाइम सिर्फ कर्व ऑपोजिट बनेगा, डेट्स ऑल, और कुछ नहीं बनेगा। जैसे यहाँ पर आपके पास कर्व हमने बनाया ना, तो हमने वी मेक द कर्व हियर इन दिस ग्राफ, कैसे बनाया हमने, कर्व इज अ इंक्रीजिंग कर्व, got
Yeah.
it? But here the load is at x-axis. If the load will be at y-axis and extension on the x-axis, that time the curve will be decreasing curve. Only the difference is that, nothing else.
Okay.
Got it?
Yes, got it. Can you send me the definition of Hooke's law and other definitions also?
I send you all the notes of the deformation.
Okay, okay.
Okay. And also this slide you need.
No, not a slide, only the definition.
Okay, I send you the definitions. Okay, anything else you want to